Okay, so maybe you're watching this video because the potential energy problems really have you stumped. Remember, I posted a separate video if you need help solving the kinetic energy problems. Now, the potential energy problems I think are easier. There's just more formulas to choose from. For instance, you have potential energy where weight is known, and you have potential energy problems where mass is known. So I'm going to do a few more example problems for potential energy, and hopefully that will help you out. So I'm going to read a problem for potential energy. This one says, how much potential energy does a 50 Newton block have when it's placed up on a ladder 5 meters above the ground? So just like the last video, I'm going to write what I know. Okay, I have a 50 Newton block. That's going to be a weight. So weight is equal to 50 newtons. And it says it's up on a ladder 5 meters high. That's a height. And it says, what is the potential energy? So my next step is to look at my cheat sheet and decide which equation I need to use for potential energy. This one has weight, so I'm going to choose weight times height. And I told you this was easy. This is just a quick multiplication problem. PE equals 50 times 5. PE equals 250 joules. Much shorter. There's no squaring of anything. It's just a multiplication problem. So let's do an example of a potential energy problem where we need to find out height. Okay, so this one says Joe has a potential energy of 800 joules. And Joe has a weight of 80 newtons. We want to know how high up is Joe. So I'm going to use a form of the same equation. This time it's H equals potential energy divided by weight. Okay, so I'm going to say 800 divided by 80. Okay, so I will give you this hint. The problems that you will have on your test are meant to use really simple problems and numbers like this. So probably most of you could do this in your head. Height equals 10, and you have to get the units correct. So what is height measured in? The standard unit of measurement for height is meters. Okay? I won't do an example here, but sometimes you're asked to solve for weight, and the equation for weight is just potential energy divided by height. Okay? Now I'm going to switch gears a little bit. I'm going to get a new piece of paper, and we're going to talk about the potential energy when mass is involved and when the little g for gravity is involved. Okay? First thing I want you to know is g is equal to 9.8 meters per second squared, but for our class we're going to use the number 10 because it makes for easier math problems. So anytime you see g or are asked for g in a problem, we're going to use 10. Okay, so that is just a standard, always the same number. All right, now let's do a potential energy problem where mass is given. So this problem says that we need to find the gravitational potential energy with a car that's 1,200 kilograms and is at a height of 42 meters. So I'm going to write down mass is equal to 1,200 kilograms and height is 42 meters. And then I'm going to put in the g because I don't have weight, I have mass, 10 meters per second squared. So sometimes that's not listed in the problem, but you're going to find out that g is required because we only have mass and not weight. And g actually converts mass to weight. That's how we figure that out. So we want to know what is the potential energy. So the equation is not much harder. It's mass times gravity times height. Okay, so we're going to do one big multiplication problem, 1,200 for mass times 10 times 42. And if you want to grab your calculator and try this out with me, I'm going to plug it in, 1,200 times 10 times 42, okay, is 504,000 joules. So some people were kind of scared off by the big numbers. Don't worry, okay? Sometimes joules can be really, really big numbers. All right, so let's do one more with the gravitational potential energy. Let's solve, how about we solve for a mass? Let's do mass. All right, so this is a good one. A diver has 3,600 joules of gravitational potential energy, and they step onto a diving board that's 6 meters above the water. Let's see if we can figure out the diver's mass in kilograms. So the problem told me that the diver had potential energy, 3,600 joules, and it said that he was up on a diving board that was 6 meters high. Okay, and it asked me to solve for mass. All right, now some people might want to use the equation for weight, but wants to know mass in kilograms. So I'm going to throw in G for gravity, and I'm just going to rearrange this equation to solve for mass. So mass is equal to potential energy divided by gravity times height. All right, not too bad, just a couple extra steps. So let's put in our number for PE, 3,600 divided by 10 times 6. All right, let's simplify that. 3,600 divided by 60. Go ahead if you'd like, plug that into your calculator. 3,600 divided by 60 gives us a mass of 60 kilograms. Okay? So you're going to want to refer to your cheat sheet. There's lots of variety of different equations to use. Sometimes you solve for height, sometimes you solve for weight. And you just have to remember when mass is involved, so is gravity. Hope this helps you, and good luck on your homework and your post-test.